So here we have this trigonometric expression and we have to prove that this is true. Now right after the bat, I just noticed two things, that these trigonometric functions, they have different arguments. So the argument of cos over here is 2 theta and the argument of sine is also 2 theta, but of cot is just theta. So that's a little bit different. Now I see that this equals 1. Now I can see that this equals 1. So right off the bat, I can take a look at my trigonometric identities. I first take a look at my Pythagorean identities. And normally you would only need to remember the most popular one, which is sine squared theta plus cos squared theta. That equals to 1. So this one over here. That's all you need to remember. And you can work with that. Now, also a tiny refresher. If you're not familiar with what cot is basically 1 over tan. Similarly, 1 over sine is cosec, 1 over cos is sec. Okay. What you have to do is I kind of want to bring them to the same argument. Either all of them should become theta or 2 theta. So let me work that way. Now I'm just going to work with double angle identities and I'll find an identity for sine 2 theta. So that comes out to be sine 2 theta, 2 sine theta cos theta. So these three identities I just copied from the formula sheet, or if the formula sheet is not available to you, then I would recommend that you just memorize these three and the rest of them you can derive on your own. So I'll just try to work with all three of these and then modify my left hand side, this side of the equation, until this becomes equal to 1. So first of all, I start by breaking down this cos 2 theta, since I see that cos 2 theta over here is isolated and I can just get a cleaner result. So once I break this cos 2 theta over here, I get cos square theta minus sine square theta. And since there's a negative sign over here, then the sign over here is going to get reversed. So it's going to be negative cos square theta plus sine square theta. Now, so we've dealt with this double angle over here. Now I'll move on to sine 2 theta cot theta, this expression over here. I'm going to find an identity for sine 2 theta over here, and that equals to 2 sine theta cos theta. Let me input that in and still multiply this by cot theta. Now, what is tan theta? Tan theta is basically sine over cos, and cot is 1 over tan. So cot is going to be cos over sine. It's going to be the reverse of tan. So I just write this cot over here. I just write this as cos over sine, and now I see that these two signs get cancelled out. So what I'm basically left with is 2 cos squared theta. And then you have these left over from the previous expression. Now when I have 2 cos squared theta minus cos squared theta, I can just basically subtract them. So this is like saying 2 minus 1, right? And then I have cos squared theta plus sine squared theta. And then I just go back to my previous identity over here, and this equals to 1. This way, this is proven. Now we have to find the value of sine 1 over 6 pi cot 1 over 12 pi. Now one thing which I notice right now is that this would be sine 2 theta and this could become sine theta, because 1 over 12 is basically half of 1 over 6. Okay, so I've written this here. 2 theta would become 1 over 6 pi, and then now what I'll do over here is I'll break down this cot into 1 over tan. I'll break this down into 1 over tan. Okay, and tan is basically sine over cos. So 1 over cot would become cos over sine. So cos 1 over 12 pi and sine 1 over 12 pi. Now let me just turn this into theta just for ease. Use the double angle formula over here to break down sine 2 theta. I've done it previously over here. Now sine 2 theta is 2 sine theta cos theta, as we see from the above trigonometric identity. Let me write this down. I've written sine 2 theta as 2 sine theta cos theta, and I can see that these two sine thetas, they get cancelled. Now I get 2 cos square theta, because these two cos's, they're getting multiplied together. Theta over here. Now I can directly evaluate this, but let me see what theta is. Theta is 1 over 12 pi. And if I'm saying sine of pi, so this angle is in radians, and I think they want the exact value. So putting this into the calculator, this might get a little bit tricky. So I would much rather go with the values or figures which I remember. For example, sine of pi over 2 or 90 degrees, it's 1. And similarly, cos of pi over 2 or 90 degrees is 0. So I would much rather go with exact figures. Now, when we are looking at the radian degree system, pi radian becomes 180 degrees. So pi over 12, this becomes 180 over 12. This is quite a This turns out to 15 degrees. Now sine or cos of 15 degrees, it's not such quite a popular number, so it's not exactly an exact value. So what I'll do is I'll try breaking this theta down into 2 theta so that I can maybe try and evaluate sine of 30 or cos of 30 because I would know the value for that. So I'll just use another double angle identity where cos 2 theta is equals to 2 cos square theta minus 1, and then my answer over here, if when I transform this identity, this is going to be 1 plus cos 2 theta. Theta is 1 over 12 pi. When I multiply this by 2, I get 1 over 6 pi. Now, since we just discussed, as we discussed above, pi over 6 radians correspond to 30 degree in angles. Now, cos of 30, it's a quite popular number. Like I know sine of 30, it's half. So cos of 30 is under root 3 over 2. That's why my answer is just simply going to be 1 plus under root 3 over 2.